Now let's come to DOTS. What is that, right? What is DOTS mean? So DOTS actually mean the difference of two squares. What does that mean? The difference of two squares. Difference of D for difference, O for off, T for 2, S for square, DOTS. This is also a very small concept. Understand it and then you will use it in different questions like this. You can see this is a question which probably be in the exam. So we need to apply the concept which we will learn here, DOTS, and the concept above. So we'll both use here in this question. We'll come to that. But let's first understand DOTS. What is that? The difference of two square, it means that a square minus b square. If you have in algebra, if you have this type of thing, how you will solve that? It is not limited to a and b only. It is possible to be as x square plus x square minus y square. Remember, there must be minus, okay? There must be minus. You can see the difference. There must be minus in between. X square minus y square, a square minus b square, z square minus y square, anything. There must be minus, both must be square. So the simple method to simplify this is to write down a plus b, bracket close, and a minus b. That is the simple version. We have simplified that. We have converted that into two brackets. It means a square minus b square is equal to a plus b, a minus b. So you can replace that a square minus b square by a plus b, a minus b. You can do that, okay? You can replace a x square minus y square as x plus y and x minus y. You can replace that. It depends from question to question. I will show you here in this example that why this is important, why this is necessary. Right, so we are doing, this is a concept which you learn that, and we will use this in order to simplify different questions, but we are coming to that. But let's practice few questions in order to understand this DOTS method. So let's take this example. It says factorize. This question says factorize. So let me write that question. Focus here. Factorize. So let me write the question, that is 9p square minus 16q square. You might be thinking that 9p square minus 16q square is something else, and what I have explained you, which is a square minus b square, is something else. By the way, that is a formula, okay? A square minus b square does not mean that you will always be given a square minus b square in order to replace that by a plus b and a minus b. It does not mean that, okay? The question could be anything. 1 square minus second term square, that is important. It could be anything. It could be 9p square, it could be 16p q square, anything. But if you read that, if you read that, if you see that square is only on p, not on 9. This square is only on q, not on 16. But this says that square should be on the whole number. It is a here. Square is on a. But here in this case, square is on p and not 9. All right. So that square is only on p and only on q. So actually the formula is a square, okay, and b square completely. Square is completely on b, square is completely on a. But in this question, square is only on p and not on 9. So we will make sure to take that square on 9 on this number as well. So how is this possible? You know that 3 square is equal to 9. So I can replace that 9 by 3 and p whole square. Now you can see the square is on p as well as on 3, because if I explained you last time that you need to apply the square on both of them. So applying the square on 3, so 3 square is 9, so you will get 9, and applying the square on p, you will get p square, the same thing. Similarly, I can replace that 16 by 4q whole square. So now this is a, that is b. So a square minus b square is equal to a plus b, a minus b. So it means that it will be 3p plus 4q bracket 3p minus 4q, and that is the answer. This is how you solve this question. Now let's do another example. So let me write the example here. Example 2, that is 3x square minus 75 y square. It is not always possible that you can make this 3 as a perfect square, because you can see this square is only on x, that square is only on y. So the better way is to take 3 common first. So let's take 3 common. So it will become x square minus 25 y square. Because converting that question into the formula, in the form of this formula, was not possible. That was not possible because 3 cannot be converted into the form of square, 75 cannot be converted into in that form. So therefore I have taken 3 common. All right, so with practice you will understand these type of things, that you need to take common, or you can directly do this. So you will learn these things with practice. So let me write 3 there. Now x square is already on x, so no need to change. But 25 I can write 5 y whole square in order to make that like the formula, like this formula. So I will keep 3. Now let's apply the formula. So it is a, that is b. So a plus b and a minus b, a minus b. So that is the answer. Now let's see the third one, that is x square minus 5. Question 3, x square minus 5. Now in this question there is no square on 5, so what to do? So in that case, this is okay, x square is all right, no problem with that. I can write under root 5 whole square. So you can see square is now there, because square and under root can cancel out with one another. Okay, so if you cancel them out again, it will be 5. So both are the same thing. So I have just replaced the 5. There is 5. I have written in the root and square. So now this is a, and that whole thing is b. So it will be a plus under root 5 and a minus under root 5. So that is the answer. All right, so this is one concept. Now let's simplify. You will see the use of these concepts which we have just learned. The question is simplify this question I'm solving. Okay, that example, x square minus 36 divide by 5x plus 30. Okay, so this is the question, we need to simplify that. So if you see the numerator, focus here on this numerator. Somehow x is square, but there is no square on 36, so somehow we can make that 36, we can convert that 36 in the form of square, and then we can apply that formula, this one, we can apply this formula then. Okay, and if you see the denominator, that is 5x plus 30. Actually, from here we cannot make square because their square does not exist with the first one. So we can take common from the denominator. So now let's solve it. X square is okay. In place of 36, I can write minus 6 square, okay? And remember there is minus in between, so then you can apply the formula. So x square minus 6 square. And I can take 5 common from these two, so 5, and in the bracket will be x plus 6. Why? Because this is actually 5x plus, I can write 30 as 6 times 5. So 5 is common, so I take 5 out. What will left in the bracket? 5x divided by 6. X divided by 6. Now let's apply the formula on the numerator. So that would be x plus 6 and x minus 6 divided by 5 into x plus 6. And now you see we can cancel out x plus 6 from here and from the numerator. So the answer will be x minus 6 divided by 5. So this is the answer. So see, you if you see, that was the question and we have used both the concepts here. We have used the formula x a square minus b square formula, and we have used taking common concept as well in one question. So this is how you need to use these concepts in different questions. So that was the question, we used both of them. So this, by the way, this is a clear indication to you. If there is x square and there is minus in the middle, so there is a somehow indication that you can convert that into a minus a square minus b square formula and then expand that. There is no square, but somehow 5 is here, 5 is there, common is, so you can take common in this question. Okay, so you can see, you can compare the answer. X minus 6 divided by 5 is the answer. All right. Now, question number 1 is factorize. Actually, you need to take common here. This is your homework. Take common. Convert this into a square minus b square formula and then apply that. Convert this into a square minus b square formula because there is square, x square minus 11. So, by the way, it will become x square minus under root 11 whole square. Okay. This is just 11. So, I will introduce under root and square both. And from the numerator here, you take common and denominator convert that into a square minus b square formula and expand that. By the way, 49, replace 49 by 7 square. So these are the two important concepts. This is enough for this lesson. In the next lesson, we will start manipulating surds.